Okay, in this video I define a relation called EO, defined as ordered pairs drawn from the integers, such that there exists an integer a such that the distance between x and y is equal to 2 times a. And hopefully you're well aware that the absolute value of the difference means just the distance between the two, and that what this is saying is that the distance between them is an even number, twice some integer a. And so the questions are very simple, are such and such ordered pairs in the relation, and it's yes on the first three because well, the distance here is 2, and so we can choose a equals 1. The distance here is 22, so we can choose a equals 11. Here the distance is 4, so we can choose a equals 2. 2, 22, and 4 are all even numbers. However, 2, 1 is not in the relation because their difference is 1, which is not an even number. Okay, I'm going to try to go on to the next problem here. And hopefully you get the idea that this relation is an equivalence relation, and the equivalence classes are even and odd numbers. That's why it's called EO. Okay, so these are even and odd numbers. The next two problems are generalizations of the first one, and here we have the same thing. We call it t, and now the distance between the two elements has to be a multiple of 3. Okay, so 3 times a for some a in the integers. And here I write out that definition. Here I've also defined t sub x as the set of all y's in the integers such that x comma y is in t. This is, if this turns out to be an equivalence relation, these will be the equivalence classes of the relation. And so tx is all those elements which are related to x, basically. And so what do we normally call this? Well, we normally call this equivalence mod 3. So it is an equivalence relation. Tx is a set of integers equivalent to x mod 3. So if I give you x, let me draw a few integers here. If I give you an x, suppose I give you an x equal to 2, then all those guys whose distances from this element are a multiple of 3 are here, etc. Okay, and if I put tx where x is 1, then I'll get all these guys in red. I'll get x equals 1. These guys are all just to the left of the blue, and if I give t of 0, then I'll get those multiples of 3. Okay, so all the blue guys are a multiple of 3 distance from each other, including a distance from themselves, which is 0, which is also a multiple of 3. All the green guys have pairwise distances between them, which are multiples of 3, and all the red guys. And this is the set of equivalence classes. So we've divided the integers into 3 equivalence classes by coloring them green, red, blue, etc. And so it asks, what are these equivalence classes? And I list them out here. T1 contains the element 1, T2 contains the element 2, T3 contains the element 3. T4 happens to equal to T1. When we start with 4 and start counting by 3, it's the same thing, same set, same infinite set is starting at 1 and counting by 3. Okay, so this is 2 problems. And I'll move to another video to finish the next problem.